Cool. So the title of my talk is Code-First GraphQL Server Development with Prisma, but really it's divided into two parts. In the first part of the talk, I'm going to talk a little bit more about the code-first and SDL-first question, and hopefully this will nicely complement the talk by Tim Greiser that we saw yesterday. And then in the second half of the talk, I want to speak about how you can use code-first in practice and actually connect your code-first GraphQL server to a database using Prisma. My name is Nikolas Burk. I work here in Berlin at Prisma. We're building database tools for developers. That's all I want to say at this point. You'll see, or you'll get to know Prisma a bit more in detail later on. And you can follow me on Twitter and on GitHub as @NikolasBurk. The agenda for today is threefold. So first, I want to start with an introduction where I'm going to do a little bit of legwork for all of us so that we are all again on the same page about the main concepts that I want to talk about. Then I have one section that's talking about SDL-first and code-first GraphQL schema construction in more detail. And then the last part is code-first GraphQL server development with Prisma, where I'm also going to show a live demo. So what are we actually talking about when we're talking about code-first and SDL-first? For that, I want to take a peek at the anatomy of a GraphQL server. And no matter which programming language you're using for your GraphQL server, you'll likely find these two components. You need to have a network layer that kind of is responsible to process the HTTP requests if it works with HTTP. And then underneath, you actually have the GraphQL schema, including the resolver system that defines the API operations, the data structures of your schema, and also is responsible for the data resolution. And today the talk really is just about the GraphQL schema. I don't care about the server, about the network layer today. Today I want to talk to you about the schema. So one really important insight when talking about GraphQL schemas is that the class GraphQL schema comes actually from the GraphQL.js reference implementation. So if you're using Node or TypeScript for your GraphQL server, then you're very likely to actually use the GraphQL.js reference implementation under the hood. And that's where this GraphQL schema class comes from. Not sure if that's actually readable, but this instantiates a GraphQL schema. And a GraphQL schema basically sits at the core of every GraphQL server that you might be working with. So here again on the left side, we have a code snippet that shows you how you can instantiate a GraphQL schema just using the API of GraphQL.js, so the GraphQL schema constructor. And we're creating the schema instance, and then no matter which GraphQL server you're actually using, you can actually feed it into that HTTP server. So Express GraphQL, for example, there the API looks like that. Then you could also feed the same schema into Apollo server and the same schema into GraphQL Yoga as well. And you would always end up with a GraphQL server running on HTTP serving the same schema. And this talk really is about the different ways, or at least the first part of this talk is about the different ways how you can create this GraphQL schema instance. So we have two approaches at the moment that are called schema-first or SDL-first and code-first. I'll talk a bit more about terminology in a second. But both are really just related to GraphQL schema construction. And a quick reminder for everybody, in case you have forgotten what the SDL is, that's the GraphQL schema definition language that we typically use to describe the schema in a human-readable form. So here is a very simple example where we define a single user type with an ID and a name field. So how do you go about creating a GraphQL schema? I want to use this talk as an opportunity to clarify terminology around code-first and SDL-first GraphQL schema construction. So we have fairly often heard the term schema-first, where the GraphQL schema is basically defined as a string. The schema definition is defined as a string, and then you implement resolver functions in your programming languages, and you map those resolvers to the schema definition. The catch here is that the resolver structure has to map exactly to your schema definition. So if you have a query type in your schema definition, then you also need to have the same query type that's spelled exactly in the same way in your resolvers so that it can map to that schema definition. Then we have the second approach that I call code first, that's also sometimes called resolver first. And with that approach, really, the GraphQL schema is defined programmatically. So you don't have this string-based API for defining a schema. Instead, you just define your entire schema in code in the first place. And we actually started to call schema first rather SDL first because it's a bit more precise. It describes a bit better what this actually is about. We see schema first, or actually schema driven, rather as a more broader concept, part of your development process that rather relates to the question if you're making the schema design a priority in your development process. Like, do people of your teams actually sit down together and think about what kind of API operations they should expose, and what priority does the schema process, the schema design process, have in your development process? And that's rather a spectrum, actually. It's not you are schema-driven, you're not schema-driven, but instead it's a spectrum depending on how your process is implemented. And one really important note about that is that schema-driven can be applied to both the SDL-first and the code-first approach. And I'll talk a bit more in detail about this later. So for now, I just want to illustrate what these different approaches actually look like. So we talked about schema first, and we talked about SDL first. And now I want to show you examples what this actually looks like in code. And I'll start with the GraphQL.js the GraphQL.js reference implementation, which we already saw a code snippet before. We just use the GraphQL schema constructor that we get directly from that library to instantiate our GraphQL schema instance. So this is a code-first API, because nowhere in there you actually see what the schema definition looks like. Then we have GraphQL tools as an alternative, and the first library that really popularized the schema-first or SDL-first approach. And in here, you see exactly what I've mentioned before, that we have the schema definition defined as a string. Then we have a resolvers object that we're defining that follows the same structure of the schema definition. And then by passing it into the make schema function, which we get from the library, we create a new GraphQL schema instance that adheres to that schema. And then we have GraphQL Nexus that Tim introduced yesterday, where we have a slightly different API than GraphQL.js, but it's just another code-first API to create a GraphQL schema instance. So the SDL-first approach has a number of really great benefits, and it's definitely a valid choice for GraphQL server development. So the schema definition serves as API documentation, which is really nice. We've all seen the GraphQL Playground or Graphical, where we can expand the documentation tab on the side, and this is enabled by the schema definition. So this is amazing. Then the schema definition can also serve as a cross-team communication tool and decouple your teams. So I've talked to a lot of people that have adopted GraphQL in their companies, and they just say, our teams, they don't talk to each other anymore because they have the schema as a common foundation. They don't need to talk to each other on a daily basis to communicate about different API endpoints or what kind of fields are being returned. So this really is a strong, strong benefit for that schema definition. It also enables quick mocking of an API. If you're using GraphQL Faker, for example, you can just feed your schema definition into it, and you basically have an endpoint that returns real-looking data. And then also with GraphQL, with the SDL-first approach, GraphQL schema design is not an afterthought. So it's really that when you're using SDL-first, you are kind of schema-driven by default, because every change that you're introducing to your GraphQL schema has to be very explicit. It has to be a conscious decision, because you're first manifesting that change in a string, which you have to type yourself without any need of your editor. So it's not an afterthought, and that also is really amazing about SDL-first. But it also comes with a little bit of issues. And this is my favorite part of this talk, because this is audience participation. Audience participation. All right. I have prepared a little riddle for you, a GraphQL server implementation that is SDL-first. And on the left, we see the schema definition, and on the right, we see the resolver implementations. And whoever dares to take a guess on that up here on stage and explain what errors they find in that implementation will win this awesome Prisma t-shirt right here. So who wants to take a guess? Anybody wants to come up on stage? You will get the t-shirt anyways. Yeah, volunteer, that's awesome. Hey,
Hi.
what's your name?
Alex.
Alex. All right. How many errors do you think you can find here?
Well, I just found one, so I came. I didn't know.
Okay, that's fair. Which one did you find?
So profile picture URL.
Yeah?
It cannot be null.
Very good.
So if it doesn't exist, the picture ID, you return null.
Exactly. We are violating the required constraint here. So that was the right guess, and you win the t-shirt. Congratulations.
Thank you.
Awesome. There are actually 5 errors in this implementation. And if you are curious about them, then you can look them up in this blog post where we also already posted this quiz earlier. I just reused it. So how much time did you spend basically figuring out what the errors in that implementation were? You really had to look closely, had to figure out, and it probably would have taken quite a while for you to actually figure out the 5 errors, if at all. So now I want to enumerate a couple of problems that the SDL-first approach has, but also already present a couple of solutions to all of these problems. So what I just illustrated on the previous slide is basically the inconsistencies that can arise between the schema definition and your resolver implementation. And like that was the example which I just showed. But there are, of course, tools to help you with that. I don't want to say that this is an unsolvable problem, not at all. So you can use static analysis tools or code generation tools like GraphQL code generator, and these will help you with that. So it's not that this is an unsolvable problem. Maybe you want to modularize your GraphQL schema into smaller components. For that, we have a tool that's called GraphQL modules. Maybe you want to import SDL schema definitions across .graphql files. For that, we can use GraphQL import. What if you want to compose your GraphQL schema? You can use schema stitching or schema federation. So there are tools that help solving these problems, but in the end, these are always additional tools that you have to learn and maintain when you're working with GraphQL. Oh yeah, and the tooling and IDE support, which you can solve by plugins for your editor or the GraphQL tag function from the GraphQL tag library. So we at Prisma, we've actually been quite a bit involved with the GraphQL ecosystem as well, and we also built a couple of these tools that you saw on the previous slide. But in the end, it always felt like we were just creating new problems. We created new problems that we then, again, had to fix with another tool. Then we created a new problem that we had to fix with another tool. So it's really like fighting the Hydra that always, when you chop off one head, grows a couple of new ones. And then we kind of took a step back and thought about, okay, do we actually need all of these additional tools? Or maybe we already have some tools that actually help us solve this. And in fact, we realized that we already have our programming languages. And the programming language, they solve all of these problems. If you're using TypeScript or another statically typed language, then you don't need to learn all these additional tools, and you don't need to maintain all these additional tools. Instead, you can just use your programming language for all of that. And that's a great benefit that the code-first approach has compared to the SDL-first approach. And another important thing to understand about code-first is that SDL doesn't go away. You can still keep your SDL schema definition as a human-readable version of your schema, but it just becomes a generated artifact instead of being manually maintained. So if we now review the benefits of the SDL-first approach, we see that, in fact, all of the benefits that had to do with the schema definition are still retained with a code-first approach. We still can have the API documentation, cross-team communication tool, and quick mocking of an API. The GraphQL schema design is a little bit more tricky because that's the big benefit of the SDL-first approach, that you really have to be explicit about all your schema changes and very conscious about it. But on the other hand, with code-first, it's still possible to make it work. It's not you can use code first and schema first or schema driven together. That's a really important realization. And code first has the big advantage that it's basically also idiomatic to programming languages. It can leverage the features that already exist in your programming language, and these programming languages, their basically standard way for creating GraphQL schemas is code first. So it's also not that this is like an exotic idea that somebody came up with. It's actually a well-proven approach for creating GraphQL schemas. So now I want to tell you a little bit more about what code first can look like in practice, especially when you want to connect it to a database. As I mentioned before, I work at Prisma, and we're building database tools. And maybe some of you have had an eye on our blog or on our Twitter this week and saw this announcement. So we just launched the first preview of Prisma 2. And the most important thing about Prisma 2 is that we now deliver 2 standalone tools that can be used separately, but you can also use them together, and of course, they are really nicely integrated. These 2 tools are called Photon and Lift. Photon basically is a type-safe database client that is auto-generated based on your database schema. So you don't have to write a manual mapping layer for your database anymore. Instead, you get an auto-generated mapping layer that always is up to date with your actual GraphQL schema. And then Lift is used for schema migrations. So you have a declarative data model, the Prisma data model definition, that you use to describe your database schema. And then you can use the Lift CLI to perform a migration and map your declarative data model to the schema. And I'll show an example of that in just a bit in my demo. And one really important thing about Prisma is that it's not opinionated on code first and SDL first. So while it might have sounded that I myself have a slight tendency towards code first, that's just my personal opinion. My role here today, or my job, is to provide you a good choice of a good set of reasons to make an informed decision yourself on which of these 2 approaches you want to use. And for that, I want to point out that Prisma is not opinionated on SDL first and code first. You can use it to build a GraphQL server with either approach. So Tim Greiser introduced Nexus yesterday. I'll build upon that by explaining how Prisma actually integrates with Nexus. So when you're using Nexus and Prisma together, the first thing that you'll notice is that you'll save a whole lot of boilerplate code that you would have to write otherwise inside your resolver function to access a database. You don't want to really write SQL statements inside your resolvers. Maybe if you're using a traditional object relational mapper, this could also lead to problems. So that's exactly why we built Photon, the database client, and we have a really nice integration of Photon with Nexus that will save you the boilerplate and auto-generate type definitions. So we put a strong focus on type safety with all the tools that we're building. When you are using when you're using these kinds of tools that go and generate GraphQL APIs for you based on some data model definition, what's typically the case is that you are not super flexible in designing what the actual API, what the actual schema should look like. If you're still maybe familiar with GraphQL, so that was the tool that we were building before Prisma, which was very much a GraphQL backend as a service, there what we provided you with was a generic CRUD GraphQL API. And this CRUD API, you couldn't tailor it really to the needs of your front-end developers. So we really just exposed a database API to the front-end. But that's not how application development is supposed to work, in my opinion, because you still want to be able to tailor the API operations to the needs of your front-end developers. And that you can't do with most of the GraphQL code generation tools. With Nexus, you actually still have the full flexibility in exactly defining the API that you want to provide to your front-end developers. And then you also get the end-to-end type safety from the database to the application layer. If you're also using a strongly typed language in your front end, you can even go from database to the front end with the end-to-end type safety. And what end-to-end type safety basically refers to is that you don't have to write manual mapping code to map between the various layers of your application. Instead, you'll use code generation tools that do this mapping for you reliably to reduce the human error, to save time writing boilerplate, and to just provide a more stable foundation for the communication between your different application layers. So what does the typical Nexus Prisma workflow look like? When you start out with Nexus Prisma, the first thing that you do is you need a database, and you somehow need to get a schema into that database. And that you do by declaratively defining the application models in your Prisma data model. So you will have a file that's the project file for Prisma that contains this data model definition. The next step then is that you're going to map those models to the underlying database. You can do that with a schema migration, with Lift, for example. Then you will generate the Photon database client and the Nexus Prisma CRUD resolvers and type definitions. And then you can go ahead and start building your code-first GraphQL server. And it's time for the demo. So this is the stack that I'll be using. I didn't bother to set up a real database for this demo, so I'm just going to use SQLite. Then I'm using Photon and Nexus and the Nexus Prisma integration. We just launched the preview of Photon on Tuesday. Our presenters at Prisma Day on Wednesday already had a lot of fun live coding with it. So I'll follow that lead like any sane person would. And then show you how you can build this GraphQL schema with Nexus and feed it into an Apollo server. So that's the stack. Let's go ahead with the live coding. Here's my editor, and I already have a GraphQL server running. That is most likely the simplest GraphQL server that you've ever seen. It's just a hello world server that implements one field. If we want to see what the schema for that looks like, it is here as a generated artifact in my file system. So it just exposes this one query. Let's quickly open up the playground to see if that works. I can even provide a name. Hello, Alice, and it adjusts to the name. All right, so the first thing that I want to do is I want to set up my database using Prisma, and then start using Nexus Prisma. What I need to do to get started with Prisma is I need to create my project file. And that's typically called project.prisma. And in this project file, I'm now going to start connecting to a database by declaring a data source SQLite. I need to provide the URL for that. In this case, it's going to be a local file that I call mydb in the same directory. And the provider, in this case, is going to be SQLite. So you can use Photon and Lift also with PostgreSQL and MySQL at the moment, and we are going to support more databases in the future as well. So now I configured basically the database that, when I'm using Lift for the initial schema migration, will be created by Prisma. I'll then go ahead and start defining my application models. And in this case, I just want to build a simple blogging application with a user and a post type or model. And I'll go ahead and define this ID field, and this should by default be populated with a CUID value. And by the way, can everybody in the back actually read the code? Yeah? OK, perfect. So what else does the user have? Let's give it an optional name, and let's give it an email. That's a string. That should also be unique. And one really nice thing about using these .prisma files here in VS Code is that they auto-format with a VS Code extension. So I can just use my shortcut, and it's nicely formatted. Now I'm going to copy that over to save a little bit of typing to create my post. So I'm going to have a title on that one. I'll have a published field that indicates whether this is a draft or not. So it's just a Boolean. And I'll also by default initialize that with the value false. And then to make it a little bit more interesting, I also want to create a relation between the user and the model. So what I'll do is I'll create the author field on the post, and that's of type user. And here we have the posts field, and that's a post list. OK, perfect. With this in place, we can start going ahead and creating the database, which I'll do using the Prisma lift CLI. So Prisma to lift, save, and I'll give my migration a name. What this now did is it created this migrations folder and also a folder that represents this migration, for example, with a nice README file, actually, where I see a nice diff of the changes and a couple of more information about the migration that will be performed. I have not migrated the database yet. That's happening with the Prisma to lift up command. And this also, at the same time, created my local MySQL database and migrated the schema according to the model and post user and post models. All right. So far, I just have the database, but I actually need to access the database somehow. And that's done with Photon. So I'm going to declare a generator right here that is also using a provider, and that's the Photon JS provider. And to then get this code, actually, I'll just run Prisma generate. And this will generate my Photon JS client into my node modules file, into my node modules folder, from where I can import it in my application code. And that's exactly what I'll do next. So here I'm going ahead and importing Photon from generated Photon, and instantiate it right away to have my type-safe database client available. New Photon. And now I'm going to start implementing a GraphQL API based on these models. So to make this a bit faster, here is my post type that I want to represent in my GraphQL schema, and my user type. And then I'm going to define the fields using the Nexus API. So this is the ID field. This is the name field. This is the email field. And the post field, the author field, sorry. T.field author. And now I have to provide a bit more configuration. And I also need to resolve that somehow, so we'll see how that works in a bit. And copy that over. Just this part. I messed it up, of course, but that should work. Title, Boolean. Please call me out if I make a stupid typo or something like this. I don't want to be debugging in front of you. Published. And then that was it on the user, right? OK, we have the relations that we still need to fix somehow, but that looks fine. Let's actually go ahead and feed that into our schema. Schema user and post. And let's go ahead and run this. All right, at least it's running. Let's add one simple operation that returns a list of users for now. T.list.field users. And here is my first the type. And see how everything is nicely auto-completing. Resolve. And to return the users here, I can just, old habits, users.findMany. I can use the type-safe data access API of Photon. So Photon, for each of my models, exposes a property, and then I can call various functions on these properties to talk to the database. All right, I think I'm running a little bit short on time, so I'll try to accelerate this a little bit, but bear with me. For the implementation of the relations right here, I can actually also go ahead and use Photon, where I'll have to fetch the post first, just the single one for who we need to figure out the author here. And everything nicely auto-completes. And from here, we have to get the author. And we do exactly the same for the user, where I also have a list. This is a list of posts. And we are returning we have to find the user. Did I find it? Yeah. User.find1, where ID parent.id. All right, so that's how we resolve the relation. Also use the posts here with our Fluent API. So that's how we can implement the operations for our API. And if I go back to the GraphQL playground where my server is running, I see that I don't get any users because I haven't created anything in the database yet. And to spare the implementation of the mutation right now, I'm actually just going ahead and creating a user in a SQLite browser. So here we can see that we have the user, and I'll just go ahead and create a new user manually. What do I do? Let's try that again. Browse data, user, Alice. Why does it? Save. That's what I wanted to do. And now if we send the same query again. OK. I'll just continue with the next and the last part, where I'm going to show you how you can now actually go ahead and save the boilerplate. So basically what I wanted to show here is you can use Photon to implement your resolvers and to access your database inside your resolvers. But when you're using the Nexus Prisma integration, you can even save a lot of that boilerplate. And that's what I want to show right now. And just for the sake of time, I'm going to use some of my predefined code here and then walk you through what I did. So I'm adding a new generator, the Nexus Prisma generator, to my project Prisma file, and simply rerun the Prisma generate command so that Nexus Prisma gets generated. And then I'll just import this part from the generated code. I set up the Nexus Prisma method. So this basically provides all the CRUD building blocks that I can then build upon to build my GraphQL schema. And I also need to configure this typegen thing for my schema here as well. And let's go ahead and rerun. If I do this now, then in my type definitions, I'm actually able to use the augmented API that was provided by Nexus Prisma. All right. Thank you. That's exactly why we're sitting there. OK, maybe I'll just show you what the final code will look like. I think I'm a little bit over time. So the final code saves quite a bit of boilerplate and uses this API here for defining your types. where like once you've fed like the Nexus Prisma thing into your schema, you can access the model property on your types and the CRUD property on your like on your type definitions, on your root types, on query and mutation. And by doing that, you can expose these automatically in your GraphQL server. So let's see if I can get that last one to work, and otherwise, you just have to find me afterwards for a working demo. Let's see, do we have the schema? Yeah, so now it works, and we've gotten the entire schema that has been generated for me under the hood. I'm reusing the CRUD building blocks from Nexus Prisma, and what you see here, all the names of these operations, the parameters, and the return data is all configurable. So while this is just the default CRUD that we provide, you can transform this into an API that actually caters to the needs of your application developers. All right, if you want to learn more about this, we wrote a bunch of articles about code first and schema first on the Prisma blog. You'll also find the Prisma 2 announcement with everything that you need to know about the preview period. And that is all I have today. Thank you so much.